here we are looking at the area of rectangles. And if you recall, in our last lesson, we looked at counting squares to get the areas. And here we're looking at something that appears to be similar, but I'm going to show you how to use formulas in this particular lesson. So before I get started with that, let me pull this down. Remember, we talked about area being the amount of space covered by a surface, by a shape. One thing I want you to notice here is that these are not perfect squares. And I copied this from the internet. A perfect square would look more like this. So these are not perfect squares. So technically, this is not proper. I'm not finding an area in square units. It's rectangular units. But for the purposes of demonstrating, I'm just going to go ahead and go with this with the caveat, with the note, that this is not to scale. Okay, so let's add that on there. Whenever you see that, that just means that something about the drawing is not exactly right, but you can apply the math concept anyway. So in our last video, to do this one, I would have had us counting the boxes. And I'm not going to do it all, but let's think through this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That's how we did it in the last video. In this one, however, I'm going to show you how to use a formula that will make this a lot easier for you. So the first thing we want to do, we have to count the number of boxes, squares, if they were proper squares, in the first row or in any row. And I see that there are 8 units. So let's just put that up here. We counted that to be 8. And then I'm going to count the number on the width. And I am going to double count this one for this purpose because I need to know how tall or wide, I guess width is a much better word, but there are 5 units here, and I do have that overlap right there. Now, if I were counting individual boxes, I would not count that one twice. But in this situation, this box is 8 units long and 5 units wide. This is a rectangle, 4 sides, 90-degree angles, and I know the formula for a rectangle is area equals length times, and you see how much trouble I'm having writing this formula. There is a shortcut. You don't want to have to write this out every time. So mathematicians say, let me just break this down for you a little bit. And I'll tell you what, I'm going to move this over just a hair to give me a little more room there. Okay, the area, remember that is the surface covered. The length is the long side times the wide side. And that's even worse to write all that out. So let's shorten it. Capital A for area is length, and I do a cursive L so it doesn't look like a 1, times width. And mathematicians don't even want to write the word times, so this is how we would write the formula. Area equals length times width. When you mush letters together like that, that means to multiply. So now you're doing some algebra. These are called variables. They stand for a quantity, but it's much shorter than writing it out. And the formula for any rectangle, if you want to know the area of any rectangle, this recipe will give you the end result. So the area is going to be, what is the long side? The long side is 8. What is the wide side? 5. And 8 times 5 is 40. 40 what? Square units. So now you are doing algebra. The area of this rectangle is 40 square units. So let's check it and see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. 40 square units. So the formula cuts out all of this stuff, and takes you directly to the answer. All right, let's look at another one. Let's do this tall one here. So you have a shape in your packet. You can flip this over and do this on the back side if you want. Now, we know this is a rectangle. That's important, because if it isn't a rectangle, if it is not a rectangle, this formula will not work. So we have a different formula for each shape, but this is a rectangle. So we have to do a little counting. We have to know that we have 3 this way. So this is 3 units. And we know that we have, get a different highlighter. We know that we have 1, 2, 3, 4, 5, 6, 7 this way. With some crossover there, that's okay, because we have 7 square units this way. So the area is going to be the long side times the wide side, 3 times 7, and this parentheses setup means to multiply. So area is 3 7s are 21 square units. It's not just units in a line, it's 21 of the squares that make this area. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. 21 square units. Okay, so this one, the area for a rectangle is length times width. So this one is 3 units by 1, 2, 3, 4, 5, 6 units. So 6 by 3 or 3 by 6, it will work either way. 3 6s are 18, so that's 18 square units. And remember, you can also write it 18 units with the little 2, that means square units. Okay, this one is a whopper, but the formula, you don't have to count boxes because you have a recipe. You have a formula. Have to count a few boxes. 1, 2, 3, 4, 5, 6, 7, that way. So 7 units wide. Imagine this is carpet for your new house. 10 units this way. So your room is 7 feet by 10 feet. How many square feet of carpet would you need? So you would do length. The long side is 10. The wide side is 7. 10 sevens are 70 square units. Or if you were doing carpet, square feet. You can also write it as 70 units square. Squares are two-dimensional. That's where that 2 is coming from. And here is a perfect square. If these were perfect little squares, this would be a nice square. That is 5 units by 5 units. Length times width will work. A 5 by 5 is 25 square units for the area of that one. And you could check all of these by counting squares, but that formula, it's like a rubber stamp. Anytime I see a rectangle, I can stamp that formula, and I can use that formula every single time to get an answer. So let me give you this question. I'm just making this one up. You don't have this one, but you could write it down if you want to. You can always pause the video. Let's suppose that I just draw a swimming pool that is, maybe this is an Olympic size swimming pool. I used to know the dimensions for an Olympic pool. This is not an Olympic size pool, but I'm just making this up. 30 feet by maybe 11 feet. So this time I do know units. Instead of the word unit, I have feet. I don't see the boxes, and it would be very hard to draw the boxes. I would have to get 30 in there this way, and I would have to get 11 in there this way in that little tiny space. So the formula, the rubber stamp, tells me what to do. The long side is 30. The wide side is 11. And I'm going to show you a trick right here to multiply this. 11 times 30. Bring down this 0. So just bring it right down here. 3 times 1 is 3. 3 times 1 is 3. So that is 330 square, not units, square feet. So on a test, if you can't see the little boxes, you can still use this formula to get your answer. So we started by counting boxes, and then we learned how to count boxes to get a formula. And now you're doing problems where you don't even see the little boxes. You're just going with the numbers that you were given. And now you're doing some serious geometry. You're doing some algebra using those letters, but those letters mean something. Don't let the letters get you upset. Those letters mean something. And this is just a short form of saying the area equals the long side multiplied by the wide side.